Hey everyone, welcome to another video in the Master Data Management in SQL series. My name is Elric, and in this video we are going to write code that will normalize the classification of tables in our system to fill the dataset table subjects, so we can slowly get to the definitions and normalizing the process in which we create indexes and defaults and all these other good system things. So we've already created our databases, our files, we've normalized the way we classify subjects in our subject table, and we classified our databases in the last video. So now we're going to classify tables. So I'm going to go ahead and begin. You can follow along if you'd like, or just watch. Either way, let's have some fun. So offline, I went ahead and added some records to the dataset class, family, and type table. The dataset class table, I added a record to basically create a space for SQL objects, SQL datasets. And then I linked that to a dataset family for both tables and views, using the same defaults that we have been using until we can get to the point where we can overwrite this. And finally, I added some dataset types that mimic not mimic exactly, that are pieces of the shapes we talked about. I know we only talked about the class, family, type base shape, and the relationship shape is right around the corner, same with the domain and shared attribute. But I went ahead and created a dataset type to classify each of these, because when you think about it, if we have a subject will have a type, and these types are the class, family, type base. So we want to know which table corresponds to which piece of that shape, and that is what we are going to do today, is create some code to browse our entire system and put datasets in the dataset table. So let's start writing some code. First things first, I'm going to have to browse every database. So I'm going to open the create file script that we had and basically take everything except the subject name. Go ahead and close that and paste it into a new window. But since we have a database table now that's full, we can actually remove this. And since we have standard variables or data types, I'm going to go ahead and alter that too. Real quick, I'm going to change my database to interface main. We do not have a synonym creator yet, so I just want to make sure that I am calling the database itself, because I'm going to save all my code in interface main. So I'm going to get the name and the database ID from the database table, where it's active. And second and third, we are going to go back to interface main and open up the procedure we created last episode and borrow some code from it until we can generate our functions. So let me do that a little slower for you guys. I am taking the system code because this is my system and this is the way I want to normalize how I classify tables. So I'm going to take this set of code, paste it at the top, and then the second set of code is the database type code down here. And I'm just going to copy this, go down to my query for my cursor, and type and system ID is the system ID parameter that we will declare in a second, and the database type ID is of the local SQL variety. I'll go ahead and remove this and this. Storing code and doing something a very consistent way allows us to save a ton of time. I mean, we're at 100 lines in no time. Okay, I'm going to go ahead and remove this because we're not going to be executing that. I'm going to go back up and declare my system system ID variable. And then for my cursor, I'm going to declare the database ID variable. Excellent. So now I know this is going to be 1, so I'm just going to run this, show you what the return's going to look like. And there it is, just the database ID and the database name. So in SQL Server, there is no one table that holds all tables in the system. We have to browse through each table and get information from it. So this is going to be the first time that we use JSON. And what we're going to do, if you can imagine, is normally we would use a temp table or a table variable and dynamically execute code to fill an object and then use that object and iterate through it. However, with JSON, we can send a parameter back and forth through execute SQL. But if we want to use a table variable, we actually have to declare that as a type. And we don't want to go and keep creating different types. We actually want to normalize how we access the system. So I'm going to use JSON to do that, and I can just worry about the variable and accessing it in the same way. But we will still need some dynamically executable code. Just say gather. So I think that best describes what we are doing. Go ahead and format these. And these will be standard dynamic SQL. All right. Initialize variables. So the SQL script that we are going to create, or the tokenized script, is is going to be, let's see, we need to select the database ID, which we're going to pass in to make this easier, and the table name from. Now that we have a database name, we don't have to do multi-part names. We can just say database name, and we know now that it's going to be, do I still have it? Yep. It's going to be the full database name. Dot information schema dot tables. Oh, I believe that's capitalized too, just for consistency. And we're going to add some where clauses. I believe it's table type. We're going to want to make sure that we get a base table. And that should actually do it for the select part of our script. Now, because we're sending JSON in, I'm actually going to declare a variable in here. Oh, never mind. I'm going to separate this out and use the parameters and make our code more readable. So I'll just copy my base and make one called parameter. There we go. Now our parameters for to be sent back to us is going to be the, and I'll just copy and paste it actually, the JSON dataset list. And I'm going to declare it as a max inside of here and mark it as a essentially input and output. Now, we're just going to imagine the JSON is nothing more than a two-value column. So, in this code, I'm going to initialize this variable to be blank, because I don't care what I send it. I want to make sure that everything comes back. Actually, that will overwrite when we iterate through databases, so I'll just duplicate this and create a full. So this will be the parameter that I send to each database, and this is going to be what I collect. And all we're going to do, it doesn't like highlighting that. Is plus the quote table name let's see, that's a string, yeah, quote plus table name plus quote colon quote the database ID quote comma and terminate. So this is one string and this is the second string, and we're going to inject the code like this, and essentially what that will look like is something like this. and that's what's going to come back. So now we have a script that's going to fill this object with a key value pair that's comma delimited, and then it's going to get returned for the current database, or for the database that I tell it to run. Now in our code, as we're iterating through databases, we should just be able to create two replaces for the base and we're going to replace the database name with the database name, and the database ID with the database ID. So when we execute it, and send our parameters, and send it our holder, because our holder is going to be blanked out every time it goes to a new database. So let's go ahead and see how that looks as an output. Oh, I totally forgot to add the database ID to the code we copied. There we go. No worries. I'm going to go ahead and execute it again. So for the most part, we get nothing back, and then we get a list. Excellent. So that's going to actually benefit us, so we don't have to create any table variables or any temp tables. Kind of normalizing how we send data across databases or even through dynamic queries. So the next thing I'm going to do is just initialize my full as an empty string. That's because you can't add nulls together, and a null plus an empty string is nothing. So we need to initialize it. And then every time we receive an output, we're just going to take the full list and add the details that we're getting back for each database. And that is essentially our code to go grab all of our tables. Now, once we have all of our tables, we are going to need a way to open it and then cursor through that information and make some decisions based on the table so we can classify them. So I'm going to do perform a couple actions on the full to get it ready. I'm going to say the full if it ends in a comma, let me get this formatted. If this object ends in a comma, then we are going to trim that last variable off. And if not, we're just going to leave it as is. And the second piece we need to do is convert this to JSON essentially, or trick it. And I'm going to add a statement and run this again so you can see the output. Select open JSON. Oh yeah, select star from open JSON. I don't think I'll need a path. Let's see if it yells at me. Oh, it doesn't. But what we got are our tables that we found in the database. Relatively fast too. So it's a really neat way to cursor through databases and not have to declare extra table types just to use the exec SQL statement. So because these are reserved words and I have no power over changing them, it's just what they are. That's going to be our select statement for our next cursor. And since we are out of the first cursor, we can essentially reuse this database ID, which will be the value. But we're going to need to declare a dataset name. And I'm going to declare a few other variables that I know I will need. So I have a dataset name. I'm going to have a dataset key name. I'm going to have the specific dataset number source, because we're going to finally generate those. I'll need a dataset type ID. And this should be an integer also. And I'm going to need some subject information. And I'll explain that in a moment. So I'm going to declare a subject name. Actually, I'm going to declare a subject type key name, a subject key name. And I need a subject type ID. All right. So Oh, I need one more ID. So we're going to see if the table already exists. And I have a consistent way of doing that. So I need to declare a DataSet ID. I'll just move that up with the DataSet columns. All right. So I'm going to hit Control R. This is the data that we're going to get back from our JSON. And this is just the key and the value being the database ID that we injected, and the key being the table name. So as we cursor through these, and I'm going to head and hide this, I'm just going to open the dataset cursor, fetch next from, into dataset name, and reuse database ID. I'm going to copy that. Get my cursor set up. Just going to copy the cursor name. And there we go. So here's where a lot of stuff's going to happen, but kind of reusing the same pattern. So I have a table name coming in, and I'll make a comment here. Dataset name resembles TBL ref dataset. Just use that dataset. Now I need to extract the dataset key name from this. And since we're consistent in naming, all we have to do is remove the first 6 characters. So select dataset key name equals right dataset name length dataset name -6. Easy enough. Now, this next step kind of goes along with shapes of data. At the end of our table names, we have a class, family, type, and soon we will have a realm. And in our data set type table, we have the class, family, type, and realm, but we have the word base. So when you think of something where, when you practice consistency, you're always going to have one of these things, or one of these 6 things. But since we normalized how we define an object, being the subject, since we normalized how we defined a subject, we can get the subject type ID from the subject table, where the subject's key name equals the dataset key name. I'll go ahead and select from the subject table so you can see that since we did declare the dataset like this, then we can easily extract that information. And the reason why we want the type ID is because the type ID will tell us it belongs to a specific shape. And if it belongs to a specific shape, it can only be one of 4 possibilities. I'm going to paste this here because I copied that key name. So now I got a subject type key name equals key name. I'm just going to copy this. I'll make my code look better. From the subject type table, where the subject type ID equals what came back, what would match our subjects. So now we can code for our different shapes. Because we can do something like we have different rules for our domain shared attribute relationship tables. And we're doing this because the base table, we really don't know if it's part of a domain or not. So we can't really identify without adding a lot of logic to see what actually it is, except if we only give it so many possibilities by classifying it. There are only going to be so many possibilities, and one of them will be true. So what I'm going to do next is go back to interface main and open the code we created last video, the database finder. And we just copied this code, but I'm going to copy the full thing again. So you can start to see a pattern emerge from this system. Get this in line. I'm just going to replace database with dataset. And we're going to remove this and change these. We have SQL and dataset also, not just database. But our family is modeled after what the object is, so we're just going to change local to table. So, this should be, yep, nope, that's correct. So if I open the, let me just clear this out, show you the key name and the type ID. So when I query this, I'm going to get a base class family type realm, or X. Because I have classified the shape as a class family type base, these are my only possibilities. And at the bottom here, I'm trying to match the end of the table with one of these, 4, which will test positive on a class, family, or type. So I'm going to get the dataset type using that technique. However, because we have base, if the dataset type ID is null and we are in the CFT base shape, or you belong to the CFT base shape, there's only one shape you can be, and that is the base. I'm going to move this down so that'll look cleaner. And pretty easy, right? So now we will assuredly get a dataset type ID from our classification using the subject. And this is where the implied key name relationship starts to take shape. So we'll be doing this a lot. So now I'm just looping through my data sets, converting something to a key name, pulling the subject, grabbing the type of subject, finding where it belongs to, class, family, type, or if it doesn't end in one of those, we're going to assign it the base because we've already assigned it as a CFTB shape, and now we'll have our dataset type ID. Oh, there's one more thing. Because this variable comes from my cursor, so it'll always change, which will cause this to always change, unless these are null. So we want to take our variables that are used within the cursor, and I like to put them at the top. There's one more dataset ID. I like to put them at the top of the cursor, and we're going to null them out. And by doing that, all we have to do is check for nulls if we don't get a return, and we don't have to do like is null blank string equals blank string. We can save on some ticks. So let me find the all right. So this is the end, and let me mark that. It's getting hard to read being so long. And if CFT be statement. So now we're going to exit the classification and assume that we have a dataset type ID. So we're just going to do a quick check again to make sure that we do. And then we are going to query the dataset table where we will be inserting our records for an ID where the name is the dataset name, because we want unique tables across our system. Actually, I forgot we use system ID on databases, so to separate other systems from ours, we're going to join on the, or filter on the database ID too. Database ID also. So when we match, we'll get a dataset ID. But if it's not there, we won't match. So if the dataset ID is null, that is when we are going to insert into our table, our dataset table. I'm going to scroll down. I'm just going to grab these columns, drag them over. I'm going to replace the brackets. I'm going to replace the brackets with nothing. So I don't like them. I'm going to get rid of the primary key. And just go ahead and format these. I'm just going to grab the column list and paste it. So I know exactly what I'm inserting. So we still don't have a group table yet. And we still do not have a specific dataset number for the dataset table. But we do have a database ID. And we do have a dataset type ID. We did get the dataset name. Inserted by system object table finder. Just a simple word. Classifier really doesn't, you could use classifier if you'd like, same with the previous procedure, but I'm going to use finder because it's just finding tables in our system. That's its original purpose. I'm not going to give these an abbreviation or a header, but we did get the key name. And I'm going to use upper on the key name because I want all of my key names to be in uppercase. We consider them case sensitive. I'm not going to have a display order or a sequence. None of these are going to be cleansable, and I don't need a cleansed ID. I'm going to say these are active and valid. But they're not deleted, they have no content, they're not on a schedule, there's no notes, and there's no security attached to it. And I skipped this because we can actually do this now, the specific dataset number source. So if it's not in the system, like we have here, we're going to get that source ID and its next value, 4. What is it from? No, it's 4. That's a sequence we declared. I'll go ahead and pull it up in the Object Explorer. So that's going to give us a unique number every time it's called. It's always going to increment up. But like row number, it requires a I'm going to just select 0 because it's only one object or one thing. I don't really need to order by anything. So, what would I do? I'm gonna null it out right next to it here. Just in case, because nothing will be inserted if it nulls out. So now, we can run this and actually classify tables. It grew quite a bit, 300 lines. But I think that went relatively quickly because most of this, 66 to 08, it's about 42 lines for an insert statement. And a lot of copy and pasted code and some comments. So I think that went pretty quickly. I'm gonna wrap this because they are reserved. I'm just browsing through my code to see if I have any red underline or anything. I'm gonna check my bottom cursor. Make sure I have my fetch next. Excellent. So, let's go ahead and select star from our dataset table, and there's nothing. And cross our fingers and press F5. And it's finished. So let's press F5 again. And we have some data sets. And now we have some specific dataset numbers. So that's awesome. I'm going to go ahead and copy this and save it in interface main under the object table finder. And I'm just going to overwrite this code with the code we just did. Create. Excellent. So now, what we have in our system so far is we have a way to create databases that will always look the same, have the same settings. So we've normalized the way to create the databases. We've normalized the way to create files. We created the subject shape first to normalize how we define data that we are going to manage, because that's really important. And by using the subject, we were able to link a concept to a structure of tables and create those tables. And because everything has been consistent so far, we were able to create some code that classifies those tables. So basically reversible. And that's an amazing thing, so I can continue to develop and create as many objects as I need for any sort of purpose that I may need in the future. I haven't been in AdventureWorks or Wide World Importers in a long time, so it's going to be really neat to see what we have to build on the fly and how fast we can actually do it. Just cutting the time in half at minimum. So yeah, I think that's it for today's episode. Hoped you like it. Thought it was pretty good. And if you have any questions or comments, go ahead and leave them below. And the next episode, we will be doing the same thing for or the next video, we will be doing the same thing for the data points. And then we will have essentially recreated information schema. So I think after that we'll be able to create a couple utilities to clean. Like we need to create a utility to fix our specific data set numbers before we can work on the relationships and the definitions. And that utility will be executed in the relationships and definitions too. So it'll be pretty good. Thank you very much again for watching, and I'll see you next time. Have a good one.